Ever wonder how a gas engine actually works? Imagine the intricate heart of a machine, a marvel of precision engineering that has powered our world for over a century. We are about to embark on a journey deep inside, flying through the complex architecture of a futuristic holographic blueprint of a complete gasoline engine. Here, amidst a constellation of gears, shafts, and chambers, we will uncover the fundamental principles that transform a simple drop of fuel into the force that moves us forward. This is the story of controlled power, of a symphony of moving parts working in perfect harmony, a mechanical ballet that happens thousands of times every minute right under the hood. Our exploration begins by zooming into the very core of the engine, a single polished chamber known as the cylinder. This is the crucible where the magic happens. On-screen text materializes. It all starts with a tiny, powerful explosion. Inside this cylinder resides the piston, a powerful plunger ready to begin its relentless dance. This entire process is a masterpiece of timing and sequence known as the four-stroke cycle, brought to life through an ultra-realistic 3D animation. First is the ear intake nice stroke. The piston glides downward, creating a vacuum. Simultaneously, the intake valve, a precision-engineered gateway, swings open, allowing a fine mist of blue-hued air and fuel to be drawn into the cylinder, filling the void. Next comes the compression stroke. With the chamber now filled, both the intake and exhaust valves seal shut, trapping the volatile mixture. The piston reverses its course, surging upward with immense force, squeezing the air and fuel into an incredibly small space. As the pressure skyrockets, the mixture heats up, glowing a menacing red, now primed for ignition and packed with immense potential energy. Then the moment of truth, the power stroke. At the precise apex of the piston's travel, the spark plug unleashes a high-voltage flash of electricity, instantly igniting the compressed fuel. The resulting explosion is a cataclysmic event, a controlled detonation that violently slams the piston back down the cylinder with incredible force. This is the stroke that generates the engine's power. Finally, the cycle concludes with the exhaust E stroke. The exhaust valve opens, and as the piston travels upward one more time, it acts like a plunger, forcing the spent gray-colored burnt gases out of the cylinder and into the exhaust system. This four-part sequence, intake, compression, power, exhaust, repeats itself in a blur, accelerating faster and faster to create a continuous rhythmic pulse of energy. But how does this violent up and down motion turn the wheels of a car? The camera follows the flow of energy. The force from the power stroke is transferred from the piston through a sturdy arm called the connecting rod. This rod is attached to the crankshaft, a brilliantly designed shaft with offset lobes. As the connecting rod pushes down, it forces the crankshaft to turn, masterfully converting the piston's linear reciprocal motion into powerful rotational motion, much like a cyclist's legs pushing on pedals to turn a crank. However, a single cylinder provides power in short, aggressive bursts. To create a smooth and constant output, most engines use multiple cylinders. Our view expands to reveal a four-cylinder engine, with its pistons firing in a carefully orchestrated sequence. One piston is on its power stroke while another is on intake, creating a more continuous flow of turning force on the crankshaft. To refine this power delivery even further, a heavy, precisely balanced disc called a flywheel is attached to the end of the crankshaft. As the crankshaft spins, the flywheel's significant mass and inertia act as a mechanical buffer. It absorbs the jerky pulses of power from each piston's explosion, and through its momentum, smooths them out into a steady, consistent, and powerful spin. The camera then pulls back, showing this smoothly spinning crankshaft connecting to the transmission. This rotational power is now tamed, refined, and ready to be sent to the wheels, ready to propel the vehicle forward. This rotational power is now ready for the wheels. Of course, the engine cannot perform this incredible feat alone. It relies on a sophisticated network of support systems, its essential life support. A three-way split screen visualizes these critical functions working in concert. First, the fuel system. We trace the journey of gasoline from the fuel tank through pumps and lines to the fuel injector. This high-tech nozzle atomizes the liquid fuel into a fine, flammable mist, perfect for mixing with air. Simultaneously, the air intake system draws in outside air, passing it through a filter to remove dust and debris before guiding it into the engine to be mixed with the fuel spray. Meanwhile, the ignition system. The engine's brain uses a computer to calculate the exact moment for ignition. It sends a perfectly timed electrical pulse to the spark plug, ensuring the explosion happens at the most effective point in the cycle for maximum power. Finally, all this explosive energy generates an immense amount of heat. The cooling system is the engine's defense against meltdown. The engine block glows red hot, and then we see vibrant coolant flowing through intricate channels cast into the engine, absorbing the waste heat. This hot fluid is then pumped to the radiator at the front of the car, where airflow dissipates the heat, keeping the engine operating at its ideal temperature. A final, spectacular shot shows all systems working in perfect unison within a transparent, futuristic engine model. Pistons cycle, the crankshaft spins, fluids flow, and sparks flash in a dazzling display of mechanical harmony, driving smoothly down a futuristic highway at sunset. What we witness is not just a machine, but a symphony of engineering. It is a testament to human ingenuity, a masterpiece of motion where hundreds of parts collaborate in a high-speed, high-temperature dance to transform chemical energy into mechanical force. It is this incredible process, this intricate ballet of physics and design, that is tirelessly powering our world.